value k, and k is greater than 0, then I take k and I multiply it by vector a. K is a scalar. K is not a vector. It doesn't have an arrow on it. So now this new vector that is created has the same direction as vector a did, but now the magnitude is going to be multiplied by that scalar k. So the size has changed, but the direction has not, okay? Now if k is less than 0, so now again, we do have a new magnitude, right? The magnitude is being multiplied by k, and the direction is also changing. So now it's going to be in the opposite direction of where it was originally. So for example, we have vector v. I want to multiply vector v by k equals 2. So my k value is 2. So it's the exact same direction. It's just multiplied by 2. The length has now changed. Okay, it's 2 units longer. It's doubled. Okay. Negative v. So now I want to draw negative v. So it has to be the exact same length that we see there. It's still going through 2 boxes, right? But it's in the opposite direction. Notice, guys, all of these vectors are parallel. Okay. 1/2 of v, well, now it has to be half, right? So that's why it's only going through 1 box instead of 2. Do you guys see that, the diagonal there? And so that's a half times vector v. And then negative 3v, well, now I got to take that vector and the red vector, multiply it by 3. So now I'm going through 6 boxes, and it's in the opposite direction. All of these are parallel. Very important. You're not changing the rise and the run, okay? So you're not changing the slope of these vectors.
What happens if you multiply a vector by 0?
If you multiply a vector by 0, then it becomes the 0 vector. It's nothing.
Okay, so it's 0 vector.
Yeah, but you're going to see that in the property that I give you, it's going to say k does not equal 0. So your k will never be 0 anyways.
Okay, thanks.
Well, but yes, but otherwise you're getting vector 0, right? Because it's still a vector, so it would be the 0 vector. Okay, so when 2 vectors are parallel or lie on the same straight line, they are said to be collinear. Recall that vectors can be translated. So parallel and collinear have equivalent meaning now. So do you guys remember in the past that collinear always meant that one line was right on top of the other? Well, that's not the case anymore because vectors can be translated. So even if the vector is not right on top of the other, it's okay. It's still considered collinear because vectors can move. Okay? All right, so in general, 2 vectors A and B are collinear if and only if vector A is equal to some scalar multiple of vector B. Okay, and notice here, guys, we say k does not equal 0. All right, and the reason for that is because if k is 0, then all of a sudden we have the 0 vector, and we can't say that that's collinear, right? No, it would no longer be collinear. Only collinear if k is not 0. All right, so which pair of vectors are collinear? So what do you guys think? Does A look like it's collinear? Yes. Are they parallel? Basically, when you look at them, are they parallel, and do they go in the same, oh no, they don't necessarily have to go in the same direction. Are they parallel? So yeah, A, yes, they're collinear. Here, we can see that k is negative here. We're multiplying by a negative value, and I can see that because the arrows are pointing in opposite directions. However, they are still parallel, and so yes, these are still collinear. And for C, very obviously, are these collinear? No, they're not parallel, so they're not collinear. Properties of vector addition. So we've already seen this. This is a repeat of what we just did. Okay, so I'm not going to repeat it again. Usually this is done the next day, and so that's why we review it again, but we literally just spoke about it less than 5 minutes ago, a little bit more than 5 minutes ago. Okay, properties of scalar multiplication now. So you have this vector A, and you're multiplying it by mn. Well, it doesn't matter if you multiply m multiplied by n times vector A. So that means the n is already multiplied by vector A first. Or if you multiply m first and then multiply by vector A, or if you multiply m and n together first, it doesn't matter. Okay, and again, that's an example of our associative law. Distributive law. Here I have some scalar, m, so it's just a number, it's not a vector, multiplied by vector A plus vector B. So what are you going to do? You're going to distribute. Okay, so I bring that m in and it gets multiplied by vector A and vector B. And we can go the other way as well. We can see here if I have m plus n times vector A, it's the same thing. Now our vector is the one that is the coefficient, right? And the m plus n are the scalars. You're still going to use distributive property there. Okay, so example 3, we have this vector x, and I'm telling you that the components of x are vector I plus vector j minus vector k. And then we have a vector y, and the components of y are 2i minus k, all vectors. And then vector z is 2 times vector j plus vector k. So now I want to express x minus 2y plus 3z in terms of I, j, and k. So what do you think we're going to do here? What do you think we're going to do? Yeah, substitution. Exactly. So I have this. Don't forget your arrows. And I know that vector x is this. And I know now that vector y is this. And z gets multiplied by the scalar multiple 3, no big deal. And it's 2j plus k. And so we're going to use that distributive property. So the first one I don't have to worry about. It can just come right out of the brackets. Here I'm going to use the distributive property. So this now becomes 4i plus 2k plus 6j plus 3k. All right, and then basically you're collecting like terms. And so I'm left with I minus 4i, so negative 3 times vector I. And then I've got 6 plus 1. And then I have k, negative k plus 2k plus 3k. And that is the vector or the expression that we wanted in terms of I, j, and k. Are there any questions? Okay, next example. Determine m such that the pair of vectors is collinear. So you need them to be collinear. So in order for them to be collinear, you know that this, they're being multiplied by some scalar multiple. So a lot of you guys should be able to look at this and just figure it out by looking at it, because we know that it has to be a scalar multiple. So I know that 3 times 8 is 24. And so I have to have the same multiple, right? So it's going to be negative 2 times 8, which is negative 16. But the whole point of doing this is to learn how to express things mathematically. So even though, yes, this is very simple, we can look at this and see that m is equal to negative 16 because it has to be a scalar multiple. But we want to be able to show this mathematically. So I'm going to show you the proper format. So we have some scalar multiple k. And we know that when I multiply this vector, so negative 2 vector A plus 3 times vector B times k, it has to equal this vector because they're collinear, right? So it has to be parallel to this vector. And so then from here, I can say that negative 2k times vector A plus 3k times vector B equals. And now we're just going to solve. So from here, I know that negative 2 . So I know this, right? Let's look at this one first because it's easier to see. You know that 3k times b equals 24 times vector b. Well, now I can divide out the vector b, and I'm left with just 3k equals 24, and you can see that k is equal to 8. And then if k equals 8, you just have to go ahead and sub in. Okay? So we pretty much did this by analysis, right? So from here, now I know that, well, negative 2k times a equals m times a, and I have negative 2 times 8 equals, right? The a's cancel. And so even though this was a very, very simple problem, I need you guys to express it in the proper way. Does everyone understand what I've done here? So I'm doing it by analysis. And I looked at this first. The reason I looked at this first is because I have a common variable there that can cancel, and then I'm only missing one variable. It's very easy for me to solve. Whereas if I tackled this first, there's nothing I can do. I can cancel out the a's, but then I still have a k in them. So I did it in stages, and I chose the one that I could solve first. Okay, next, simplify. So I have vector AB minus 2 times vector DE plus vector BC minus 2 times vector EF. All right, so how can we do this? So you can add vectors. Remember, guys, when we're adding vectors, they always follow, right? So if I have vector AB, for example, let's say that that's vector AB. And then I have this vector BC. That's going to come next. And then what would come after that would be a vector with starting with C, which unfortunately I don't have. But I do have a DE. I have a negative 2 DE. So let's just say pretend that that's it. And then I have an EF. So because this is now negative 2 DE, I'm going to have to change the direction of something so that I can start with my E here. And that's what we're going to do. So algebraically, I have AB, and I'm going to pair this with BC. The reason for that, again, is because of the B's. And before I go on, I'm going to simplify this, even though I'm not done on that line. Oops. So this now is going to clean up to be vector AC. AB, BC gives me vector AC. Okay? Now, I have this negative 2 DE, which is causing me a bit of a problem because, actually, no, not really. I've got DE, and here I've got minus 2 EF. We're good. Notice I've got my E's together. Thought I was going to have to change one, but I don't. And so now what we're going to do here is factor out that 2. And so I'm left with just 2DE. And now I can conclude that this is just DF. Now, let's say that the DE and the EF didn't have the same scalar multiple in front of them. Could I do this? The answer is no, you cannot. They must have the same scalar multiple. You must be able to factor out that scalar multiple in order to do this. Okay, so if these were not both 2, I would not be able to do this.
Miss, I think there should be a plus in the brackets.
Yes, thank you. I factored out my negative. Thank you. And that's another important thing too, right? We're always adding. So notice here it's DE plus EF, okay, to give us this. So if I had, for example, DE minus FE, I could then change it to DE plus EF, right? And we are going to manipulate vectors in that way. Okay? And you always, always, always have to have addition. Okay, so you can't have this. This is no good. Cannot have this. Okay, so what you can have though is that, because now I can change this. Do you see that? That's okay. This is not. Okay, I hope that makes sense. Okay, so let me ask you this. Can I do this? Can I add those?
No.
No. Unless there was a 3 here, I can't. Or if there's no 3 here. Okay, so good. Just want to make sure everyone's got it. Good, excellent. A unit vector. So what is a unit vector? A unit vector is just a vector with a magnitude of 1. So basically, to find a unit vector, all you have to do is divide by whatever the magnitude of that vector is. So for example, you have this vector v. And let's say that vector v is 11 units long. Okay, that's the size of vector v, 11 units. Then to find the unit vector, all you have to do is keep that vector v, but just divide by the magnitude of it, which is 11, right, to get 1. And that's essentially what we're doing here. We're keeping that vector v because I need the direction, right? I need the same slope in that vector, but I want it just to have a length of 1. So I divide out whatever the length of it is. Okay, and then to clean it up, I just bring that vector v into the numerator. Okay, so let's take a look at an example because usually that makes life easier. So I have this vector A and I know that it's 11 units long, and I want to find a unit vector. Notice, guys, it's got a hat on it now. So that's what tells me that it's a unit vector. So all I have to do is I keep that vector. I want the vector to be the same. I need the slope to be the same. I need the same direction. However, I want a magnitude of 1. So I just take that vector and I divide it. And I divide it by 11. Do you guys see that? Good. I have a vector u, which is 5 units, and I have a vector v, which is 8 units, and the angle between the two vectors is 60 degrees. Okay, so remember, guys, when we're talking about angles between vectors, it's always tail to tail. So I don't care how you draw these. It doesn't have to be in the same direction as mine, but try and make the angle between the two vectors to be approximately 60 degrees or something that acute, basically. Make sure that they're acute, right? I mean, you're not going to get exactly 60 degrees. So here's my vector v, let's say. And here is my vector u. And again, you might have chosen to do it the other way. You might have put u where my v is, right? And v where my u is. And that's okay also. What I want you to notice is that I've sort of made this longer. I'm trying to show that it's 3 vector u's. Okay, so here's vector u. Then I've got 3 of them. Okay, so multiply by 3. That should be a little longer. Okay, that's 3u. Angle between them is 60 degrees. There you go, tail to tail. But now I want to do 3 times vector u plus negative v. So negative v. How would I draw negative v? What would I do to draw negative v? Well, I'm going to take v. That's it. Same slope, opposite direction. And I can take this now and I can put it anywhere. So I'm going to take this and I'm going to put it here because I want 3u plus negative v. And now my resultant is going to be from where I started to where I ended up. That's the resultant that I'm looking for. Now, we know that u is 5 units. Well, if vector u is 5 units, then the triangle that I've formed, well, this must be 15 units because it's times 3. And then I know that vector v is 8 units. And that's vector v, so there's my 8. So I have a triangle now. How am I going to solve this triangle to get the magnitude of the resultant vector? What do you guys think?
Z
Well, I
pattern.
have, yeah. Okay, good. So by the Z pattern, I do have a Z pattern. So by the Z pattern, I can see that this angle is also 60 by the Z pattern. Okay. And now I have a triangle. It's not a right angle triangle. So what law am I going to use, guys? What am I going to use to solve here? I've got two sides and I've got the contained angle. So what am I going to use?
Cosine law.
Cosine law. So again, you're going to see the math is very simple. It's just my cosine law. So go ahead and do this. Tell me what you get.
So missing the question, there should be vector arrows, right?
In the question, oh yes, I bolded. Do you see how mine are bolded?
Oh yeah, yeah. Okay.
Yeah, I bolded, but you're right. Yes, if you're writing it, always arrows. Okay. So you're doing your cosine law, so you guys should know how to do this. And what do you get, guys?
$13.
Good. Exactly, Brian? I believe so, yes?
I think so. Yeah.
Yeah, I think so too. Okay.
I also got exactly 13.
Perfect. Thank you for the confirmation, Nicholas. Okay, so find a unit vector now in the same direction as this vector that we just saw, that we just found. Well, we just found out that the magnitude of this vector is 13. So if I want it now to have a length of 1, I just have to divide by 13. So I take this vector. So here I know that this vector is equal to 13, the magnitude. And so to find the unit vector, I'm just going to divide by 13. And to simplify, we're going to do the distributive property. Okay. And there's your unit vector. Are there any questions? Okay, now determine the direction. So I'm going to have to draw again. I need that drawing back. Actually, I might just copy it and paste it. It might be easier. Let me see if I can do that. Come on. No. There we go. Okay, so it's here. So now we want the direction of our resultant. So which angle am I looking for? What do you guys think? Does anyone have any inkling which angle I might be looking for?
The one in between the black, like the one
Yep.
pointing east, and the green.
Good, excellent. That's the angle we want because that is the angle from where we started, where we began, to where our resultant ended up, right? So that's the angle that we want. Okay, so what information do I have? I have a 60 degrees to the right here. I want to find the angle theta. I've already solved 8, 15, and we know that the resultant is 13. So another piece of information that I have there. And so now what law can I use to solve for that angle theta? I don't want to have to use the sine law again. Excuse me, the cosine law again. I just gave it away. So instead, we're going to use the cosine law. So the sine of theta over the sine of, over, that's not good. So the sine of theta over 8 is equal to the sine of 60 over 13. And so now I have the sine of theta equals 8 times the sine of 60 over 13. What's the sine of 60? Do we know the sine of 60? Could we find the sine of 60?
Square root of 3 over 2.
Yeah, we do. We know it. And so if I ever asked you for an exact answer, you would be able to give me one here. Okay. Now we are looking for this. So I'm just looking for the inverse of sine. And so theta is equal to, what does it come out to be?
32.2.
Okay, so 32 or 32.2 degrees approximately. Good. Oops. Are there any questions?
Yeah, Miss, I have a quick question. Can't you find like an exact number for the unit vector for the number b?
What do you want? You want the exact, it's 1. We know that it's 1, it's a unit vector.
Oh, so it's always, okay.
Unit vector means the length is always 1. That's why I'm just dividing by whatever the magnitude is. So I just divide by 13. If it had a length of 20, we'd divide by 20.
Okay.
Okay, so now what's important here, because this is where a lot of you guys struggle, is how we write this. So we're going to say, therefore, the direction of 3u minus v is 32 degrees, okay, easy. Now, what is the direction of it? What is it doing? Well, we're measuring it from u. And now we're going to say it's away from v. Why is it away from v? Well, because this angle here is in the opposite. It's not touching. It's not anywhere close to where v is. V is here. Yes? And so it is away from v.
Miss,
Yes.
could we also say clockwise?
No. No. I want you to use this terminology. So from u away from v. Sometimes it could be from u towards v.
So could it also be 327.8 degrees towards V?
Hold on a second. 300, because you want to talk. Wait,
Yeah,
I don't
the
get it.
other way.
Oh, you
The
want to
other
go
way.
this way?
Towards V. Yeah. So would it be
No, we would
327.8?
never. No,
Oh,
we would never
don't
do
do that. Okay.
You want to know why? When we're doing this, we always work with acute angles. We never work with obtuse angles or reflexive angles. Always working with acute angles. Okay? I'm sorry, sometimes you will be using obtuse angles. Sometimes you have no choice but to use an obtuse angle, but you will never use a reflexive angle, ever, ever, ever. Okay, are there any questions?
Miss.
Yeah.
So if it's a obtuse angle, would it still be, like, for example, in this case, would it still be from u away from v?
Yeah,
Okay.
well, it's hard to say. Let me go back. So how do you want to draw it? Depends on how you draw it. So what do you mean by obtuse? So if it came out, it couldn't be in this case. Right? It couldn't be. It's just not possible. But if you did have, let me try and think of an example to show you. Okay, here, I have an example. Let me think of an example. So let's say I had this. And so now I'm going to translate my V. Let's just say it's like this. So there's my V. Okay, I've translated it. And so now my resultant is this. Okay. And so now here's my angle theta. So here you would say angle theta is from U, but towards V.
Okay, thank you, miss.
Does that make sense or no?
Miss, can you repeat that? It wasn't really.
Here you're from U, so still from U, but you're going towards V. Do you see that? Because look, the angle between U and the resultant is like this. Do you see that? Whereas before, it was like this. And so you're going away from V. Do you guys see the difference?
Yeah.
So
kind of.
another way to think about it, the resultant is between U and V. Do you see how the resultant is between U and V in this second example? And so you can say that it's going towards V. Whereas here, in this example, it is not between U and V. It's outside of it. And so it's moving away from V. Maybe that's an easier way to think about it. Okay. Are there any questions?
Miss, when is the unit test for this unit, this chapter?
I have to check. Let me look. I have it written down. I just don't remember offhand. Well, actually, it might be in our calendar. Let me go check if it's in the calendar.
I think I said Friday.
Let's see. Yep. Oh, look at that. It's actually pretty. I made a little pattern. So yes, your chapter 6 test is this Friday. Your chapter 7 test is next Thursday. Your chapter 8 test is Wednesday, and your CPT is on the 26th.
Wait, so what
Yeah.
are we doing after the CBT? Nothing?
So nothing. So the reason I need to do the CPT so early is because I need time to mark it and do report cards. Because I think our last day is the Friday, correct? Or is the Friday a PA day? Anyways, I don't have my schedule in front of me, but so you guys are gonna actually have 3 days off. Like you're gonna have a nice little break before you start your next quadmester.
Okay, thanks.
Cool? Yeah. Okay, so I will post the lessons, guys. The recorded ones are there, so I don't think you need, actually, you know what? I'll post the PDFs as well. So I'm gonna post the PDFs for you. The homework is there tomorrow. And then tomorrow we'll be doing, I believe, 6-5 or 6-6. I'm sorry, I don't have my schedule in front of me, guys, but yeah, we'll be doing 2 more sections and I think we're done. We're done chapter 6 already. It's very quick. So that's it. So try not to fall behind, guys. Do your homework. I'm here for another hour if you have any questions. Just let me know, okay?